Hi everyone, we'll get started in just a sec. All right, so I think we're going to start this live webcast. I had some folks on our Discord channel ask me to do their live webcast. This is a great time for people that are tuned in on live to ask questions during chat. Don't know how many people we get on. I kind of don't pre-announce these things. I just kind of announce on Discord, hey, I'm going to go live. I've been working with this beast. This is a S17 Plus hash board. It has 65 chips on it, which is a lot of chips, and it's quite a bit different than the T17s I've been working on. And I bought this board. It had been damaged in shipment. It had ripped out chips. Kind of hard to tell because of the light, but let me see here. Bring this camera right down close. You see where I've replaced chips, like here, all the copper chips I've replaced. Well, I started using my same process as I doing the T17, and I really wasn't doing so good replacing these chips, so I had to look for a different way, and I found a different way. So I thought it might be a great deal to share. Hey Brian, how are you doing? Thanks for joining today. So I thought I might share the process I use for changing these chips. I think I've got it down now. It took some tweaking from the T17 process. Essentially the T17 board has probably this many chips compared to this. There's a lot less metal in the board. There's a lot less heat sink. There's a lot less chips. So I was having a hard time replacing these guys because it was getting so I couldn't get it hot enough, and you got to get it hot enough to solder. So tonight I'm going to do a little bit of diagnostics. My process has been I put all the chips on. Most of them didn't take, and so I started. Of course, I put them on, I do the test, it's 0 Asics, which means there's usually not power flowing through the clock signal or the RO signal on the chip. So I start testing this, and what I've been doing is just working on the chips until I can get the clock signal all the way through. Then I'm going to have to probably redo a couple other ones that I don't touch to get the RO signal back through, and then I should have a register. Then I really kind of have to test the quality of what I'm doing. So you can feel free to ask me questions on chat. In fact, there will be some quiet times when I have to actually put this on the board and I have to wait for it to heat up. So the first thing I'm going to cover is let's just say you have a board like this and it's 0 Asics. How do you know which chip to work on? The S17 Plus board is pretty nice, like the the T17 board, is it has these little test things. There's 5 little test points before and after each chip, and the way the chips flow here, this is chip number 1 and this is chip number 65 way up here, so they kind of do this all the way over. And so you start here, and I started here, and I'm just working the clock signal through all the places I screwed it up by not putting a chip on correctly. I won't show tinning the chip. I've already got some pre-tin chips. I'm just going to use those. So if I pull one of these off, I'll pull it off and I'll use a pre-tin chip. We'll have to work on the environment on the board before we place that chip, and I'll try to show as much as possible. So, okay. So I have a fluke meter. Bought this with a kit from Zeus a long time ago, a beginning kit. Probably made more for S9s than the 17 series, but it kick-started me into this. And I have the test fixture, which is the Antminer test fixture. I have it all hooked up. I have a bench power supply here set to 21 volts. It's off right now because I've been messing with the board. It takes a long time to test. Usually on the T17, I hit it. Just in a couple of seconds, it throws voltage through. I can test it. It goes and leaves fast. S17 Plus is a little bit different. It takes a while to warm up, applies voltage for a really long time, and then I have to restart it. And I only want to do it a few times because there's not many heat sinks on this, and actually some heat sinks are missing on the back. so I don't want to overheat the chips to do this. So, thank Drake's. Hi Drake, how you doing? Thanks for that. Okay, so this is typically the setup from Zeus. I've got a positive and negative. I have a needle with a broken tip, which I still wish I had my tip because these dudes are really small to poke into. But I use this and I set it on the voltage. And then what I'm going to do is I'm going to turn on my power supply, and I've got my tester all booted up. So let's do that. Oh, and be sure you pay attention to how you hook this up. This is exactly opposite of the S17 Pro and the T17. The positive goes here and the negative goes here. So I always have to take my time and check. I have to admit I've burned up a board once doing that, and so I try to be really careful doing that. So, oh yeah, Drake, you know, if you go to our Discord, there's actually a video on how to test the salvage chips, believe it or not. And essentially, I'll tell you what, I'll save the tutorial for while we're waiting for this to heat up, if that's fair enough. I can't show my power supply, but I can describe it for you. If you want to hang out till I have to throw this board on the heater, I'm going to have to throw it on twice, so it'll be sooner than later, okay? Okay, so I'm going to power on the power supply, 21 volts. And I'm going to hit the test button. And then what I'm going to do is, I just worked on this chip, and I'm going to show this chip under the microscope, and I know it's kicking out. The clock signal is right there, and it's got some, geez, I wish I could get this out of the shadow. There you go. So that's just the control board power going through it, but watch, as soon as the power starts feeding, you'll see it has 0.8. And I'm going to start walking the board as long as it's got power going to try to find this. So it is feeding power now. Just a sec. Get it on there. And that's not my clock signal. Sorry, the clock signal's down here. So there's the clock signal. 0.8, 0.9 is good. I'm going to walk over to the next chip. 0.8, 0.9. I'm going to walk past the next chip on the clock signal. The last one I replaced. 1.7. Still passing voltage too. So all this is okay. So the voltage goes up and around. I want to check the clock signal on this side. And I'm too late. I gotta wait for the cycle to finish. So I'm up to this chip. The clock signal is passing all the way through here, up through here, up through here, and around through here. I'm testing it down to here now because this is the last line of chips. So I'm not happy with the solder job on this chip. I'm probably gonna have to replace it, but the clock signal did flow. So I'm gonna leave it alone right now. Probably have to return it on my RO. These have been reworked, and I know they're good. Okay, still 0 Asics. So I'm going to hit this again, and let's line up. Let me see, the clock signal is on the inside. So this will be the clock signal here. We'll see. So you see the power supply, the controller power on that? Just watch. I'll tell you when the power supply starts pumping. Not yet. There, okay, it's pumping voltage now. You see the voltmeter, 1.8 or 8. Probably some LDOs are old, but that's fine. I'm going to go to the clock on this side. And there is nothing. And so, just double check, going in, coming out, nothing. It's about ready to die for me. Some of the other voltages are probably okay. That just died for good. Well, I know clock, which is on the outer line coming through here on the outer test line, is no good. So this chip is not passing through the clock signal. It's not getting to any other chips, so I've got to deal with this chip first. It's kind of in a real hard position. It's in the middle. So yeah, I knew this before the video, but I want to show you how I diagnosed it. It's pretty clear that no voltage is getting here because I did a bad job soldering the chip. So we're going to look at this guy. So let's go for that. I'm going to take this off. And the first step is I'm going to remove my power supply. Remove the testing stuff. And then let's kind of drill in and have a look at that. And I want to show you what a good soldering job looks like and what a bad soldering job looks like. So we'll throw this under the microscope real quick before we turn on the heater. Yeah, these S17 heat sinks, man, they just fill up your desk like crazy. So let me see, that's we're going to look right here with the microscope. I just don't want to get the glare of the light in. So sorry if I missed it. Are you using a bench power supply? So Brian, no problem. I was using a bench power supply just to test. I have changed the configuration on the tester to only check for Asics, not to run the board. So that's an important distinction. I have an APW9 right next to me. I use a really long extension cord on 220 to get it here. But just the bench power supply for testing these things. Had some problems before. Right now I can test voltage and it's going to tell me the truth of what's going on though. So we've identified this chip being bad. It's because I soldered it bad. Let's just let me raise this up a little bit. Let's have a look at this with the microscope. Okay, let me flip video sources and let's have a look at this. All right, come on around here. I'll move the board around a little bit. So I want to show you a good solder job. This is the one I did last night. And so when you're examining a soldering job, a couple of things to look at is, did you blow out any of these resistors here? It looks like I'm missing one here, but that's stock with the board. This is kind of the R address thing. But do you see how those nice balls are right there? If anything, this chip encroaches this way a little bit on these balls and made them smaller, but I've pretty well got it squared up. Do you see the nice balls on there? That's where you want to get to. Now let me show you a bad solder job, which is same person doing it. This is the chip we identified as bad. This chip slipped over to the right this way, really shorted us here. Probably is not connecting over here. I can't ball up the solder because there's so much room for it just to grow here that it's not good. So this is when I didn't know how to heat the chip up enough and it moved on me because it had to stay there a long time. So we're going to take this chip off and I'm going to throw another one on here, and that's what we're going to do tonight. So that'll be the subject of tonight's thing. And the S17 Plus is just a little bit different on how to do it. Okay? All right. So hang on. Turn off microscope. Let me fix this guy up a little bit. Maybe bring him in a little bit if I can. So I have a hard time getting heat. What I'm going to do, which is just the opposite of what I would advise you to do the T17s, I'm going to remove the heat sink. So let me get some heat going here in my air gun. Let me identify where this dude is. So it's this heat sink. Let me see if I had a marker in here. Where the heck is my marker? Just so I don't blow it. That's the heat sink we're going to get rid of. And all it does is it's absorbing so much heat I can't get the chip hot enough. So I've got a hot air gun. This could be probably 375 degrees. I've got it on something a little higher right now just because I use it to replace chips. But let me see. Yeah, got it. Just checking messages. So I'm going to try to get the air down in there without killing the board. I'll probably go this way. We'll just wait for it to warm up. Gotta heat all that stuff up. You don't want to pull it real hard. You don't want to wiggle it. The best you can do. There's a lot of stuff in here. I kind of heated something up too high up here and messed up an LDO and then replaced it on this board. I've done everything to this board. This is my learner board. So I'm just, it's kind of out of the video picture, but I've got the hot air gun just basically laying on that dude, and I'll test it once in a while. It will get warm enough. Smells good. There we go. All right. So I know that's not going to hinder us in heating up this chip, so he's gone. Now, don't forget to put them back on after you get your chips all working to even do a hash test on it. So, okay. So the other thing is, I think when I heat something up to take it off, I like to be able to kind of play out with my fingers where it is with my tweezers. I've got these tweezers. I've got really good access off this side. So I'm going to have to do it. All the power connections up here, so I'm going to move my 1000B board holder just a little touch, and let's see if we can get it this way. These holders aren't necessarily so important when you're taking a chip off because you just want it to get hot, but I'm learning to to use them quite a bit. See, I think that should be on the hot plate. Okay, so I've got it on the hot plate. I'm going to flip this guy on. I've got the hot plate set for 185 degrees. I actually cranked it up 5 degrees. I'm going to let the board heat up for a while now. It says 28 degrees Celsius. I'll let it go for a while. The longer it sits, the easier it is to work with. And while the board's hot, I'm going to come back here and I'm going to condition the pad. So while we're doing that, somebody asked a question, how in the heck do you test a bad chip versus a good chip? And I wish I could get my power supply over here, but that's going to be impossible. So I will describe it. But I do have my power supply cables. So if you need a notebook and paper, or you can go to our Discord server and search, there's a small iPhone video that shows how to do this. And you have to test a couple chips to kind of get a feel for what's right. I've obviously got some bad ones here. Let me see. Oh, maybe I didn't stack up the ones that were totally trashed from having the chips pull them apart. Maybe this is one of them. I've got some real bad ones in here. I got whole piles of them. But so basically what you do, the big pad is the negative, and the small pad is the positive. Maybe I can, should I do the microscope kind of? Just so you can kind of see, and I'll kind of talk through what's supposed to happen for you. So, wait a minute. Okay. So basically, if you write these volts down, you set your bench power supply to 1.42 volts. So you set the power supply on, it's hot. Let's see if I can get this stretched far enough, or I'm going to have to move this over just a sec. So you have 1.42 volts, and you're going to have to watch the power supply and do this at once, but I'll put the negative on the chip right here. I'll put the positive here, and then you watch your bench power supply on how many watts and amps it's drawing. And this chip should slowly climb up. If it goes really up high, like into if it jumps up to 0.8 or 0.7 right away and just shoots up, it's not a good chip. If it goes too slow and never goes up, I don't think it's a good chip. But if it's kind of just a slow progression, you kind of see the chip warming up and working better and more voltage flowing through it, that's the chip you want to keep. So you're just going to have to experiment, and you'll kind of know, get some purposely bad chips. A lot of chips you pull off they'll show that they're good, and they're not though. So this isn't a foolproof test. I've had problems with some of the chips. I pulled, what is that? Well, that's just that dude. I pulled a bunch of chips off a board that had been burned severely, and evidently it sent some bad voltage to the chips and just fried them, but they passed this test, but none of them had an RO signal ever. So you gotta, it's a good way to recycle chips, but you might be replacing chips 2 and 3 times if you don't trust your chips. So this isn't foolproof. So I hope that answers your question. So we're up to 164 degrees. Let's sit and watch that dude. Okay. I'll move this back a little bit. So this is my 1000B. Even once it gets up to 185, I'll let it sit for a second or two. I don't have a heat gun. Someone said you should get a heat gun. I just make sure I fill it, getting warm. Still got a ways to go. It's getting there. Some people have a hard time taking the chips off, and that's probably just because they're not getting it hot enough. Let me see. Yeah, Brian, I noticed that I saw that message on Discord right before I started this. Sorry I didn't answer you. I do harvest boards. Check this out. This is a burned S17 Pro board I bought. I got it on eBay for $50. I got a real bargain. I've used every single one of those chips off that dude. I have a couple left that I'll get. These are bin 2 chips, which are supposed to be special for bin 2 boards. Actually, that's a bin 2 board, but I'm not doing that. I'm just going to try it. This board was absolutely fried. And I did harvest all the parts. I've harvested lots of parts. I've taken some LDOs off there. Might take some temperature sensors, but I think these are the ones I have brand new. And I've messed up some stuff on the back. I've stolen some stuff off the back. So yeah, use your boards. Make sure when you harvest it, it's really irreparable though, because you'd hate to waste a good board though. So for sure. Hi Javier, how you doing? Thanks for joining. We're heating up an S17 Plus board to remove a chip, then to put a new one on. If you haven't known earlier. You've been on before, right Javier? I think you have. Kind of remember you. Of course, there's probably lots of Javiers too. So, okay, we're at 185. I'm just gonna help the cause by throwing some flux on there. Now remember, I took the heat sink off, so right now this is going to be cooler than the rest of the board, but I'm really just trying to get everything hot enough, just so it flows easy. So I think it's not as important than putting it on, so I think I can probably pull it off. So I have my heat gun set to 455 degrees centigrade. I will, I'll heat it up, try to pull it straight off so I don't blow any resistors out of the way, and then we'll start working the board and preparing it. So here goes. Fan all the way down. You don't want hardly any air going through. Let me find a place for my elbow here. Just see if we can heat this guy up enough. Hopefully we can get it hot enough that it wants to just come off really easy. I have a fume extractor I'll turn on too, so might get a little noisy. So usually I just look for the legs to start twinkling and I know I can pull it off. I tried with this chip though and it just wasn't getting hot enough. Okay, I see a little bit of the solder melting. See if we can pull her off. There we go. Okay, so that's the chip. I'll turn off this heater. And now we have something to work with. So I'll rig up a couple other things. I do some things normally that I probably won't do. We'll take a look at the quality of the board, but I think on this side I can pick it up. And bring it on down here. Alright, I'm going to switch views. So let's take a look what we have here. Let me find it in here. Ooh, where are you? Right there. So, and I may do this, but normally if this were a regular Bitmain chip that had been soldered with no lead solder, I would use some solder wick and I would pull all the solder off, including the legs. I know I've already done that with this, so I know this is leaded solder. There's not a lot. It looks okay. So I'm not too worried about that. But what I am worried about is getting the legs retinned. And I want to check the legs. So let's clean this guy off with alcohol. If some legs creeped because of heat, because of me trying to work with it the wrong way, I want to fix that. And sometimes that takes a little detour into the solder resist paint. So let's just use an alcohol, and I use paper towels to wipe that off. They seem to soak up the flux really good. So alright, let's have a look here. So I think the legs are in pretty good shape. The chip moved. You can tell before when I was doing this, I blew away this resistor, so I've replaced this with a larger resistor, just larger in size, not any larger in ohms. So looks like a lot of dirt here we need to clean off. Just wondering about those resistors. Anyway, I think we're good to go. If you really have to spend time. So this board joins the circuit board, I think right there, and it joins it. I don't see another place over this side. I think it goes over right here though. It also does a circle right here. These two legs are the same, so this is harder to heat here. This guy looks like he's bulged up. So what you're looking for is if these things burn up into the legs and you've got this really long soldered place. This one's getting kind of longer. You can see how it's elongated a little bit. Probably not bad enough yet to worry about, but it's getting there. Like if it grew like that much more over into here, I would have to stop, clean it off, and put some more solder resist, the green stuff on, to stop it from traveling. That in its entirety could stop your chip from setting. So let me see, I have a question. Peter, I just got the hashboard code editor. Okay, so you use the code editor if you look in your error logs and you see an error called error EEPROM. If you see an error EEPROM, you need to use your code error. That means the EEPROM memory storage on the board was trashed somewhere, and using the test fixture trashes it. That's the only time you need the code editor. I have a great video on that code editor, so for sure. So, all right, welcome, Peter. I've talked to you on YouTube chat before, right? You still need to try to get that Discord. If you can do all this stuff, you can get on Discord for sure. So, I think you really wanted to tell me you didn't want to figure out Discord. If I'm wrong, I apologize. So, anyway, I'm going to clean this guy up a little more. Let's, while the board is somewhat warm, let me get my soldering iron going. I'm going to put this kind of out of the way. What tip do I have? I have kind of a really big tip right now. I'm going to use it to retin this. So let's get that turned on. I have about 350 degrees on it. And hopefully I can have a good time doing this and not destroy anything. Sometimes I do destroy stuff. Let me wipe off the... Yeah, I remember your name, Peter. The guy can work on hashboards, but he can't learn Discord. So you need to learn Discord. There's so much information there, it's unbelievable. There's a lot of great people on there. Okay, so I'm waiting for a second for the tip to warm up. I've got it set for 350. Usually if I don't let it run for a while before, it's kind of rough. Okay, so what I'm going to do, I don't want to just go along here without any solder on the tip of this dude. So I have this, it's going to be blurry, SMDSW, Chip Quick. This is 100 and, you see, this is 182 degree melting temperature. I have a little tiny ball of solder you can kind of see on it. Hopefully if all goes well and I have enough flux, I'm just going to go like this and redo these things. There, just like that. Then I'm going to do this side. They weren't bad in the beginning, so, and I know they're the right solder. If this was leaded solder from Bitmain, I would completely take solder wick and remove it. I've still got enough solder on this to do this again, so let's go. I don't like what I did there. We flattened it out, so let me, ran out of flux over here, so let's, there, got it. All right, so let's clean that up and inspect it. So whether or not I'm entirely successful tonight, this is the process. And if I'm not entirely successful, I'll do the same process till I am. So, you know, sometimes on live video things don't work out. Okay. So I've got that kind of cleaned out. That looks pretty good. It looked almost pretty good, you know, before I Jeff, oh hey, crypto miner, thanks, good. All right, so that looked pretty good. What I do is I kind of cheat and I lift this dude up and try to get my microscope to just, I kind of like looking at the landscape going down. Let me get it in focus. I mean, all those dudes are kind of uniform, sticking up. I kind of like that. Same with this side. Look at that last leg down there. Yeah, so I think we're in pretty good shape to put a chip on here. So all's good. Let me get back to where we're at here. All right. So for those of you just joined, I'm using a different process than the T17 on this S17 Plus because it's so heavy, has a ton of metal in it. Can't get the chip, can't get the solder hot enough. So I've heard of people reducing the melting point of the solder. I didn't want to quite go to that extreme. So I am using the right solder, but I pulled the heat sink off the back, which is just the opposite of what I would do on a T17. I actually use the heat sinks to heat it up. But I have had some luck by getting it in there this way. So now I'm going to find one of my pre-tinned. I need to look at these chips. I tinned them and I fixed them. So that side has pretty good cut. Let's look at this side. It looks like it might have a flat spot in the middle. After you tin it, you always inspect it. You want everything perfect on there. So this looks like a pretty decent chip to put on. So I line these guys up. Whoops, I don't drop it, but I line it up because that side's going to go with that. And you might have a leg that's deficient here, and if it's two deficient legs, one on the chip in there, I wouldn't do it. I'd go fix one or the other. Let's try this. So I mean, I'm pretty comfortable doing this. So let's get ready to do this. I'm going to turn off the soldering iron. We're done with that. I think I'll use the same setup I had as far as laying the chip out on the hot plate. I think I got there. Let me see something. I just want to make sure yeah, I'm okay laying it out on the hot plate. So the next step to do this is not to throw a bunch of flux on here. Yeah, ask your kids, Peter. That's how I learned. I hate to say. So I learned by myself, but I asked them to enhance it with me. So they're partially responsible for the Antminer repair Discord. So with this flux, you don't want to just flood this dude because I don't want the chip traveling once I start heating it up. It might be contrary to some videos on YouTube, but it's really difficult once this thing's moving around and you got a hot plate going and a lot happening. The chip just doesn't find its way back. It'll find its way half back. There's lots of places it wants to stick, and some of them are not in the right place. So, I mean, I just put for the first phase of this, I spread that out. Maybe a little more down. That's on the heavy side of the flux, okay? That's on the heavy side of the flux, because that's just the base, so I'm not touching the legs. I do put flux on the base, not too much. I just kind of keep it thin if I can. I want it to stick when I put the chip down and position it, so. Alright, so now that doesn't mean I don't use a lot of flux. What the process is here is I'll put the chip on here, I'll position, I'll get it just right where I want it. I don't expect the chip to move again. Once it's on there, it stays. I'm gentle with it. I get it to the heater. The flux melts out. It sticks to the solder. It may even start melting the solder. In fact, I'll heat it up so where it kind of is sinking down into the solder. Then I'll nab it with my tweezers, push it down, fix it, let it cool just for a second while it's still on the hot plate. Then I'll add flux, and then I'll do one final time. And it could be I can repeat that process a few more times if I've just got some areas of the chip that didn't melt and I know there's legs that just aren't balled up. But let's try this. I'm gonna put my fat fingers in here, and then we'll work it around. So just get it close. Sometimes I get it right on. It's kind of a game. Can't get it to drop. It's right on. Ooh, close. All right, let me find my favorite set of tweezers. It's not quite right. Every board is a little bit different because it goes through a machine and how they position it. This board seems to go well with both the bottom line and the top line equidistant open. How I can tell that is that pin down there is like right on the edge of the chip, so I know that one's probably okay. This one's sticking up, so it's not quite even. So I'm gonna very carefully, using my two-handed held tweezers, just roll this down just a touch. Then maybe the whole board, the whole chip just down a touch. And I need to clean my tweezers. Hang on. Shouldn't be sticking. No big deal. You just start back over again. So let's go down from this angle. and straight down a little bit. Now I'm just the opposite, but I prefer to push up. We got a stick here over here. One guy's sticking over here because it's sticking out. I probably have one chip service up. Let's take a look at that. Still too high on this corner. Okay. So by eyeballing that, it's pretty centered. I'm still a little bit low on that, but I think I'm okay with that. If I look where this is hanging, there's some space here, and I look where this is hanging, there's some space here. So I think I'm okay with this. It's got flux. I just need to heat it. It needs to do its job. And if I'm lucky, I don't move it. When I go to push it down, I'm good. We'll be good. So let's go position this on the heater. So let me see, Peter, how do you remove the glue from the top of the chip without damaging it? So this is a brand new chip and it doesn't use glue, Peter, but if you're working on L3s, and stuff, you use heat, probably. And if you ever have a chip that has solder on it, you would never remove it. You can, I suppose, you just wouldn't remove it. So you leave it on there, so when you put your heat sink back, it just uses the same solder to solder it on. I have a new video, if you didn't see it, on soldering heat sinks. So, all right, so let's get to the overhead view. Move the microscope out of the way. So I'm pretty comfortable how that looks. So I still need to get this dude so it's on the plate good. I'll let it down easy, no jostle. Let's see here. So this chip is a little bit this way, but some of it's because the flux is hiding it. So I think we are on the burner. I think we're pretty level for the most part. Let me see when I push down here. It might have a tendency to go that way a little bit. I can throw some support down there maybe. I just want it level. And I turn that guy on. And we wait. This chip is still a good chip, probably. I just tried to put it on and missed. I'll put it in my stack of rework. While that's heating up, I got this new tool off the Discord. I think a couple people wanted this tool. So I got this new tool here. See if I can get the light off of it. And it's kind of an interesting tool. It's a VGA rework vise. I think that's what they call it, reballing. But I can actually take a chip I need to clean up and stick it in here upside down. Maybe I'll move the microscope in there. Just a second, let me do that. But that's heating up, we got time to kill, so. You can see, just a second, let me turn on the video. You see where it's being held in there. So it's actually viced in pretty tight. So what I'll do here is this chip, this is probably the chip I pulled off actually, maybe. I'll get some flux on there, clean it all up. I'll get some solder braid and I'll remove all the solder without being too hot. I kind of stay around 300 degrees. Clean all this chip off, and then you can run it back through the stencil to re-tin it. So that's kind of a new tool I have for recycling chips for that other conversation on how to test chips. So, all right. So that's kind of cool. I'll leave that guy in there reminding me I need to do it. Okay, we're at 141. The weight. For sure. So Peter, did that answer your question about the glue on the on the chip. It's funny, other people are talking on Discord, so I keep seeing it. Hopefully someone doesn't try to call me. Don't you guys dare. So my temperature is set to 185 degrees on the hot plate. I'm going to let it sit for a while because we don't have a heat sink under that thing. So I want to get the whole board warm down there. So we give it just a sec. So far the chip is looking really nice where it's sitting. Some of the flux has run away. Hey, I wonder if I could do the microscope. I'll do it for a second. Let me see if I can do this. Hang on. You can kind of see what it looks like. Hang on. Alright, let's see if I can get this underneath there and adjusted. So I don't want to mess up the chip job I just did, but it might be too high and I can't focus it. Or way too low. Oh, hang on, someone's trying to call me. Okay, hang on. Sorry about that. See if I can get to the, there's the test. So probably in some. Trying. That's him. That's who we're heating up right now. I think. Yeah. So you see the solder's kind of getting a little shiny. I mean, it's nice and clean and shiny there. Yeah, that's my finger. That's kind of what's going on there in the heat. It's starting to heat up, so. Someday I'll try to figure out how to get a camera really close up and do that. I just haven't had the time. So let me flip back on the big view. Move this back down. Okay, good. Let's see here, we need some light. About right there. Right on the chip that's heating, so we're doing this chip right here. So it's at 185. I'm just going to hang out here just a minute or two more. Chances are the chip will not move now because the flux has gotten warm and kind of just melted away. Some of it went to the pad. Some of it went to the sides. These boards are real touchy about hitting the resistors when you're heating them too, so it's pretty common you're going to take out a few resistors. But resistors are cheap. You should order some. They're all the same size practically, the ones you're going to take out. So just order some so you're not get so upset when you push one out. There was a guy on Discord today that he was trying to repair it. He bought the tools, he was doing it, and he blew out a resistor and said, "That's it, I'm quitting." He put his boards up asking for someone else to repair them. It's like, come on, guy. Resistors are part of the game. So it's easy to get frustrated this. So let me see. Peter, you wanted me to oh, you're going to have to watch the video again. You're going to have to seek back there, Peter. Sorry. I can't go back again. Sorry about that. I'm sure everybody else wants to hear that again. So, all right, couple more minutes. I'm going to check my heat gun heat. We're all set for that. Make sure all the cables are out of the way. Make sure I got a clear path with my favorite pair of tweezers that I use to do this. I can rest my hand, it's not going to be too hot, so that's good. So I think we're almost ready. Let me feel the chip beside it. Yeah, we got some good heat there. Hopefully if everything stays still, we're going to get a good take. You're a gentleman, Peter. Thank you. Okay. I'm going to have to do this chip too. It got screwed up. So I'm going to go this one, then probably this one. These three are keepers. But those 4 chips, probably. I think this one might be good. But this one, and this one I'm really expecting after work. What a waste of time. I didn't get them hot enough. Okay. Shall we try this? If it's not hot enough, I could always go in again because I know I can get it hot enough. So I have my flux here for the second phase of this. I have my tweezers ready. I'm going to put this up. I use my elbow to Probably be in the way of the camera, sorry. Let me raise the camera up a little bit. So I'm going to start heating that chip, and I'm looking at the legs. And I'm waiting for them to melt, and then the chip will fall into them. You'll see it. It'll kind of just dip down, and they'll do some weird stuff. So again, I'm just using the flux. Just using the flux that I put on the legs that you saw me in the microscope. So, but when I see it dip down, which is starting, which means I got it hot enough, which is good. Let it try one more time. Making sure everybody's happy in there. Not sure this side is, the left side, so I'm just going to keep this on a second. Good news is it hasn't moved. Boy, I sure don't like that left side. Like hard to melt solder or something. I'll just keep heating it. Okay, I'm going to go ahead and seat this for the first time, then we'll add some flux that'll help it heat. So I'm pushing on it. I'm still applying heat. I'm just applying pressure and I'm heating it just to get it hotter. Okay, so I'm done there. I'm just going to hold this for a second. Okay, I think we should be good. Now is when I come in with the flux and go at it again. Then I'm liberal with the flux. I just let it have it all over. Okay, so let's do the same thing now. It's still warm, so it won't take very long. It's going to suck my smoke out of there. Just let it go on up again. It's very unlikely to move at this point unless you move it physically. Okay, that should really be good. Yeah, everybody's good now. So let me apply some pressure one more time. Just a little bit more heat. Hopefully my resistors made it. I don't know. I'm not too worried. I don't get too upset about that. Okay. So I'm going to pull the heat off. Okay. I really stab that dude and keep him down once he's down. So hopefully I didn't lose my resistors. We'll take a look at this now. So let me pull the board off. I pull it off while it's hot in case I have to go another round. So I didn't lose any heat sinks. I'm going to set it here. We're going to look at it in the microscope. So let's bring this dude out. Let me get the microscope lined up for you. Where are you? Kind of give an idea how our solder job went here. I'm going to turn it on. Okay, this is the chip. And so I'm liking what I'm seeing. Do you see the nice balls there? It looks like the chip basically stayed where I wanted it to. So you see those nice balls there? That's a pretty good job. I've got nice balls here. You see that? I'm missing one there, but I bet when I take the flux off it's there. If I'm missing some on this side, I'll throw it back under the heat and I'll apply a little bit more pressure on this side this time and get that out. So a little worried about that point and that point. Not so worried though. It's there, I think. We're going to clean off the flux when it cools off. We'll be able to tell. So. Oh, thanks, Peter. I appreciate it for sending it to Reddit. So, do I know how to detect a delayed Asic? Javi Cell, would you tell me what you mean by delayed Asic? You might be using Google Translate, I don't know. But Brian, I got to show you this board I got. I don't use ultrasonic for this. This board's pretty pristine. So again, this is cooling off. Let's let this cool off for a second. I want to show you another board. Just saying, I'm going to move the microscope out of the way so I can move this. I'm going to hang this kind of above the heater. I'm going to have to get one. Now UL3 guys, I don't know if Crypto CHR's on. He's used to seeing this stuff. I bought an this is an S17 Plus board that someone decided they wanted to glue all the heat sinks on. And this probably isn't too bad to take off, but they also used they tried to hide the fact that the board didn't have chips. So check this out. They put this silver stuff right on the base, no chip at all. I can use heat and get a lot of this off of it, but this is all over the chips. Almost every chip has this on it. It's crazy. Here's this one. So I'm going to clean all this off. I've got some acetate to clean it off. I've got some heat to clean it off. And these boards are filthy, so I'm going to buy an ultrasonic cleaner and get it through. So, oh, Javier, okay. Well, tell me what your problem is. It detects 64 ASIC, not 65. So, anyway, I wanted to show that to you. It gets worse. I mean, all they did was glue everything on here and make a mess. So I don't even know if this chip's good or fry the board because it's undoing. So, ultrasonic cleaner is going to be in the works soon. So Javier, if you can catch the very beginning of this video, I showed measuring the clock signal. You have to use those 5 test points. Now if it's at chip 60, so it's going to be at 2 places. Hold on, I got them. Let me change views here. You guys don't want to see my desktop in a microscope. So. Okay, I'm going to bring it over here now. We'll go back to the microscope in a sec too. This board's still really hot, by the way. But this table can handle it. But 64, Javier, means it's found this many chips going this way, backwards on RO, or it's found this many chips using the clock and all the other things. My guess is you've got 4 lines going this way that have failure. Probably this chip I would start looking at, and I'm just guessing. But you've got to, let me see. If I check all resistors and capacitors and change ASIC 65 and put 64 continues. So if it says it found 64, usually it means 64 chips are good and it's not talking to 65. The problem with this chip is when it's done, it goes back in here. So you got to follow where it goes back in here. Maybe this is 64, I'm sorry, I'm opposite. It goes back in here probably to, I haven't got that far on this board. Should be a serial communications like on the other side of the boost circuit. Here's just power. Yeah, I haven't, oh there it is. Maybe. This guy right here, if you can see, on the back side of the board there's a special LDO. He supplies the power to the last chip. Probably goes through the board on the other side. You need to kind of look at this and make sure you got power going into the last part of the chip. Okay? Oh, okay, you got the clock signal with this up. It's got to be something with this. If you find 64 chips, it's either here, I think this is here, or there. Focus there. Man, I'm going to get an oscilloscope soon, so you're one ahead of me on that. Okay, I want to clean this up a little bit. Let's look at what we really have. So I'll bring the microscope in a second, but let's clean off since I didn't blow out any resistors, maybe we can test it too. With hope I see a clock signal, but let me just start the cleaning process on this guy so we can really see it, because I may have to heat it again. I just dab this and it comes up pretty good. Okay. Let's take a look at what we have in the microscope. Change the view. Find the chip. See how good we really did. So a lot of times I tilt this dude up and try to go in. So I think we did pretty good. There's probably not much wrong with that soldering job there. Let me see. Sometimes you can put alcohol on it and see through the leftover flux. That's a pretty nice job on that chip. That means we got it hot enough by pulling off the heatsink. So let me find this side of it. Hang on, it's going to be blurry for a sec till I find out what we're... Okay, I'm trying to get to this side of this chip. So this chip, this side, remember I was complaining it wasn't getting hot enough? This was the side. This is probably okay. But it didn't get as hot as the other side. You can tell they're not as melted. You can still kind of make out the chip legs. But it did push solder out, so I think we're still pretty good. So I really like examining the solder job, how that goes. So I'm pretty sure that our chip will work. So why don't we test it? I know it's still hot, but I can test the voltage. So let me get rid of the microscope view. We'll go back to how we started this video altogether. This is going to be a little hot. So let me get positioned here. So let me see. Test fixture data line. Power. Make sure I put the right power on. Okay, so I need a bigger desk. It's not going to melt my soldering iron. Let me make sure you can see all this. Okay, so I'm going to test that chip. I'm just looking at clock signal. So, all right, turn on my power supply. Voltage looks good. Get this away from it. Okay, we're going to initiate the test. Remember I said it takes a second, so I'm going to find the clock. Should be coming in. So we see the controller power going in right now. As soon as the power supply, as soon as it turns on, you see it bump up. We had voltage on this side before. We're looking for voltage on the other side. Okay, so I got 1.7. Let's go look on the other side now. I got to be careful here. Yeah, come on, baby. Yeah, it's going to run out before I get that in because I don't have a needle. So guess what? I don't see any voltage, so I might be missing a resistor here, which I have to check because the other chip was like that. Oh, it's off already. Hang on. We'll do it again. Just a second. Okay, just 1 second. It's pretty slow, this tester on these big boards. Okay, it's starting again. So the other thing is it could be this over here that's causing the problem too, very well. So right now the clock is on the inside. So I'm not even seeing the control board pump through here. Now it's pumping voltage through. So I know if I switch to like the I'm not getting any voltage through here. So what I have to do is now go look at the power, because I'm pretty sure this chip is on good, for sure. So one thing I didn't do, we can do a diode test on it, but I'm pretty sure it'll come out okay. It's a diode test. No, look, I have a short. Check that out. No, there it is. It's got voltage. So that's the diode test. That's about right for this board. So I'm going to check my resistors and stuff, and it could be this guy is interfering if it's shorted in any way, but it wouldn't be. So unfortunately I don't have the results I have out of this chip replacement, but I'm going to either try to reseat this side of the chip again, because remember I said it looked more like legs. So I'll heat it up again the same way, but push a little more on this side and give it more time to melt. Then I'll try again. Or it could be a missing resistor. I really didn't examine all the resistors, but it looks like they're all on. Okay, so you got a couple questions, and then I'll conclude. I'm gonna use the same process, guys, so I'm not doing anything special. It either takes or it doesn't. Probably could have heated it up longer. So let me see. What bench power supply? It is one off of eBay. I think I posted it the other day. Does it have a name? Long Way, LONGWEI, and it's a 10 amp adjustable power supply. So you get a 10 amp power supply. Because I know I'm pumping out like 5 amps when it's testing. So it doesn't have a timer. I just watch it. I can see when it's drawing. So okay, thanks Javier. The diode method's good, but it's still not pumping through, so I'm going to reheat it again for sure, which is part of the game. It's going to stay on there. It's a good solder job. It's not like what I did last time, so I'm really happy with the solder job. And if I have to push it hard on that side and get connection, or if it's a missing resistor, or it could be an LDO on the other side, I don't know. I didn't know the state of this board when I got it, so it could be some other issue I have to still research, but pretty happy with the chip replacement. So. All right, so last call on the questions. I know this is going to stream after I cut off. I'll watch this. Peter, get on Discord. I think all you guys are. I know Brian is. I know Javier is. So, yeah, thanks for tuning in, guys. I hate to keep just doing chip replacements, but this was something new I discovered. Secret to S17s, S17 pluses, hold on, is to remove the heat sink. Remove the heat sink. That's not the advice I give on T17s though. So you can get the guy hot enough to do a good job. Okay? So I hope you guys have a great night. Thank you for watching, and catch you on Discord.